Okay, solving linear trig equations. We've been given this equation here. It says solve cos 4x is equal to -1/2 over root 2. So we're looking for the many different x values that will give us this when plugged into cos 4x. So first thing we're going to do is we're actually going to try to figure out what angle we're working with here. Okay, so the idea is, think of it like we're isolating for x. So we're going to take cos and we're going to move it to the other side. In other words, solving for an angle, right? So what that ends up being is we'll get 4x is equal to, this becomes cos inverse, right, of -1 over root 2. Now, you can remember your unit circle for this, or you can use a special triangle. And with your special triangle, because there are technically 2 of them, we'll figure out which of the 2 we're going to use, okay? Do you remember the 2 special triangles at all? No? Okay, one of them is 1, 1, root 2, and the other one is 1, root 3, and 2. And these 2 become 45 degrees or pi over 4. These 2 angles are the same. And in this one, you get 60 degrees, yeah, and 30, which are actually a sixth and a third, pi over 3, okay? But anyways, so we need to find this cos relationship, okay? And remember cos, well, I'm kind of right on the side here. Cos is essentially equal to, or cos theta, theta is kind of what we're solving here, that's our 4x, our theta, is equal to adjacent over hypotenuse, right? So we're looking for where the adjacent is a value of 1 and the hypotenuse is root 2. Well, that means we're working with this special triangle here, right? If it's this angle, this would be my adjacent, this would be my hypotenuse. So what is this angle here? Well, we know it's the same, so the angle is pi over 4, okay? So in other words, what we're finding is, we'll take this equation, rewrite it, 4x is equal to cos inverse of -1 over root 2, right? Okay, so we've rewritten it, but because this is negative, we have to be aware of our 2 quadrants, right? So we look at our cast system, and we have CAST. Well, this is when cos is negative, so the 2 quadrants where we're negative are quadrants 2 and 3, right? Right here. So for quadrants 2 and 3, and remember we discovered that 4x was equal to the idea of, or the angle of pi over 4. We got to find out what angles would be pi over 4 here. So we go from the horizontal pi over 4, right? So we go this distance here being pi over 4. What would this total angle be? Okay. And if that's pi over 4, we know this is technically pi, so it's like we're subtracting pi over 4. Yeah. Right? So what does that angle end up being? Do you know? Yeah, so it's the idea of pi subtract pi over 4, which is really 4 pi over 4. Okay, yeah. So when you get it, you get 3 pi over 4 is one of them, right? And the other one, because we're in this quadrant, same idea, we have pi plus. Exactly. So we take our pi plus pi over 4, which is the same as 4 pi over 4, which gives us 5 pi over 4. Great. So we have those 2 values. Those are really important to us. So this is kind of where like our equation splits, right? These are our quadrants when we're, oops, sorry. These are our quadrants with our pi over 4. So we have 4x is equal to 3 pi, there you go, over 4. And 4x is equal to 5 pi over 4, because those were the 2 quadrants where we were negative. Yeah. All right? Then from there, we isolate for x. So to isolate for x, we bring 4 over in both equations. So x is equal to 3 pi over 16, and x is equal to 5 pi over 16. Okay? And we forgot to mention that there were parameters, but we're looking between 0 and 2 pi, right? So what we also got to figure out is our period for cos. So we know that cos x, the period is normally 2 pi. But since we're now dealing with cos 4x, we take that period and divide by 4. So our period is now pi over 2. And we'll show you that with decimals, right? We had it right here. We talked about this just before. That becomes 2 pi, the normal period, and then cos 4, our period now becomes half pi, right? So we have our new period. So what we do is we take these values, and we add our period, because we know we're sinusoidal, to both of these. So we're going to make two lists. List 1 for x is our 3 pi over 16. And list 2 will be 5 pi over 16. And then we take our period. Now, because our period is pi over 2, we got to make it into a base, or a denominator, sorry, of 16. So that's the idea of 8 pi over 16. So we continuously add 8 pi over 16 to both of these. And we do that until we get to, because we have to be between 0 and 2 pi, well, 2 pi is also the equivalent of 32 pi over 16, right? So that's got to be our stopping point for both of these. So we kind of set this up, and we continuously add. So 8 and 3 adds up to 11 pi over 16, right? We add again.
21 pi over 16.
Actually,
oh, no, 19 pi over 16.
Yeah, 19 pi over 16.
And the next one's 27 pi over 16.
Yeah, 27 pi over 16. And then what would happen to the next guy?
Too big.
Yeah, the next guy would be too big. Technically, what would he be? He'd be 8 plus that is 35. Right? 35 pi over 16 is outside of our range of 32. And then we do the same process with this one. So 5 and that becomes 13 pi over 16. And we add again, 21 pi over 16. And we add again, 29 pi over 16. And then the next guy, obviously, is going to be outside. So you end up with 1, 2, 3, 4, 5, 6, 7, 8 options for that scenario, right? And we could technically show that on Desmos. Cos 4x equal to negative 1 over root 2. I think we can bring it up. I think Desmos will do it as a actual value. So what I'm going to do is I'm going to actually find out the decimal value of this. 1 divide 2, where's my root, equals 0.7. So it's negative 0.7, I think, is our idea. So in this blue one, hopefully we can get into it, negative 0.7 is somewhere around here. Yeah, it's probably just before that, right? So you get 1, 2, 3, 4, 5, 6, 7, 8. How many answers did we say we get? 1, 2, 3, 4, 5, 6, 7, 8, right? So there's 1, 2, 3. Oh, good, I can zoom in. Here you go. So remember, we're within 2 pi. We're going from 0 to 2 pi. And remember, the period is here. So 0.7 is somewhere in here, right? So we know that we're going to get 1, 2, 3, 4, 5, 6, 7, and 8 answers. And we could actually find them on the graph if we zoomed in far enough and actually followed our values. We could find out exactly where it is. Actually, our 0.7, negative 0.7. That's our y value we're looking at. So it's like here-ish, right? That's the idea. Because this isn't done in actual radians, I wonder if I can do it in radians. Oh, there you go. That would have been nice. See, and we can find it right across there. Anyways, that's the idea.